Hey, what's up everybody, and welcome back to Coding with Roby, where we go over all new things code to keep you updated on modern tech. In today's video, we are going over part 2 of our FastAPI tutorial, where we will be implementing a database. Alright everybody, let's pick up where we left off. So we left off by creating a new book class, which is part of Pydantic for our data validation. We have a books list where we are appending to the books list and returning the books list and removing from the books list, all based on the CRUD operations of the RESTful APIs that we're passing in. We have an app.get, which is our read API, which returns all the books in our list, post, which creates a new book and appends it to the list, update a new book that is already in the list, and then delete a book that is already in the list. And now for this video, we are going to be creating a database and connecting all of our CRUD operations and our FastAPI application to a database, so we no longer have to handle it within a arbitrary list that gets reset every time the application is reset. So a database definitely makes sense in this application. So the first thing we are going to do is create a database.py file. And this database.py file is more or less the configuration that we're going to be using to manipulate and create a database. And now we're going to be using SQLAlchemy. SQLAlchemy is the ORM, or Object Relational Mapping, for our database. So our SQLAlchemy is going to be handling all the behind scenes code to be able to manipulate and change our records within our database. And SQLite is a requirement for this video. So if you do not have SQLite installed on your Windows or Mac machine, feel free to jump over to my video where I walk you through step-by-step installation of SQLite. And once you install SQLite, come back over and we'll install and set up FastAPI with your new SQLite installation. Before we get into that, let's create our database.py file. So we can right click on FastAPI and say new Python file, and let's name it database. And now once we are in here, we're going to have to install SQLAlchemy. And it's a fairly easy install. Just make sure you go into your terminal in the directory of the project you're in. Again, I'm going to be using a virtual environment. You don't have to be using a virtual environment. If you do want to create a virtual environment, go check out the first video where we go over virtual environments. However, here I'm just going to say pip install SQLAlchemy. And just like that, we installed SQLAlchemy into our virtual environment. Let's now do some imports. So the first import we're going to say is from SQLAlchemy, import create engine. And from here, we're going to create another import. So from SQLAlchemy.orm, import session maker. And lastly, we're going to say from SQLAlchemy.ext.declarative, import declarative base. All right, now we have all the imports we need for this project. And I will zoom this in a little bit so we can see better. From here, let's say SQLAlchemy underscore database underscore URL is equal to double quotes, so a string, SQLite : //books.db. And this books.db is going to be created automatically by SQLAlchemy into our application. And the SQLite // is just finding the location of this books.db file that's going to be getting created automatically. All right, and now we need to create a new variable, engine, which is equal to create engine, and then as the parameter we're going to say SQLAlchemy underscore database underscore URL, which is the variable we just created, comma, and then we're going to say connect args for connect arguments. And this is a SQLite specific argument where we're going to say check same thread of Boolean false. All right, and now we're going to create a new session local. And our session local is going to be equal to session maker. And we're going to be passing in 3 parameters: auto commit, which is equal to false, auto flush, which is equal to false, and bind equals engine. And last, we're just going to say base. So base equals declarative base, and make sure base is capitalized. This is everything we need for our database.py file, where we are doing all of our connection processes to our SQLite database. And just for reference, if you do not have SQLite 3 installed on your PC, whether it's Windows or Mac, go check out my video on how to install SQLite on either one of the operating systems. I put it all in one video, and then you can jump back to where we are now. Next, let's create a models.py file, and our models.py file is going to more or less be the table and the columns of our books file that we want to put in the database. So let's right click on FastAPI and create a new Python file of models.py. Once inside the models.py file, we're going to have to do a couple imports. So from SQLAlchemy, we're going to import column, integer, and string. We're also going to import base from database. And again, I'm just going to make this a little bit bigger so we can see. All right, and now let's create a new class of books, which inherits base. And then inside, I'm going to say underscore underscore table name underscore underscore. And that is a SQLAlchemy specific thing to be able to name our database table, whatever we have after this. So after our table name, let's say equals books. So now our database table is going to be called books. And now let's say inside our books table, we want to create columns for our records of books that are going to get saved to the database. So here I'm going to say ID, and yeah, we're using UUID currently in our books.py file, but we're going to change that to now use IDs. So ID equals column, integer, comma, primary key equals true, which primary key is our unique identifier of each record, and then index equals true, and index just means when we search for this specific column, which is ID, we can get some cache and we really accelerate our search results. So since we're searching by ID a lot, since that's the primary key, we're going to say index equals true. And then we're also going to want a title column, which is equal to column string, author, which is equal to column string, description, which is equal to column string, and rating, which is equal to column of type integer. All right, so now we have our database.py file created, which has all of the settings and parameters to be able to set up a database instance. And now we have our models created, which is going to be the table within the database that we are creating. Now let's go back to our books.py file, where we can manipulate some of the code to now automatically create a database, automatically create the books table if it does not already exist, and then we can connect all of our CRUD operations to now use the database that we're creating. So one of the first things we're going to need to do is import our database and SQLAlchemy things. So under UUID, let's say import models, which is going to be import our models.py file. Let's also say import engine and session local from database. And then let's say from SQLAlchemy.orm, import session. And we don't need this comma right here, so let's delete that. All right, and now under app equals FastAPI, let's say models.base.metadata.create_all, and we're going to pass in the bind equals engine. And here, when this gets ran, this is going to create the database and table if it does not already exist. And now we need to create a new function, and this new function is going to be called getDB. And really what this is going to do is we are going to create a session local instance, which is creating our DB instance. And then we're also going to be closing the instance. And now database connection processes are usually a singleton type of protocol. So every time we open a database connection, we want to make sure we close the database connection. So we're going to be creating a function that kind of handles that process by itself. So let's start by saying def getDB, empty parentheses, and then we're going to say try db equals session local. Yield db, and then I'm going to say finally db.close. Okay, this is looking really good. So now the first thing we need to do is just start changing some of this code. So this ID equals UUID, we can delete this completely. And the reason we can delete that completely is that we're going to be having our database handle all IDs and auto increment and handle all of the ID management on its own, which removes any kind of ID management from us, which is perfect. We don't have to pass in an ID at all. And now let's scroll down to our read API return books. And now this is going to be the very first thing we manipulate. And now we're going to be using a dependency injection platform on FastAPI. So every time this function gets called, we want it to automatically open up a database session and automatically close that database session. So let's go to the very top, and in FastAPI, let's add a new import of depends. And now within pretty much all of our parameters, we're going to be calling our dependency injection. So within this parameter, we're going to say db of type session equals depends, and we're going to be passing in our getDB function as the argument and parameter. And we're not going to be passing in the parentheses of our getDB, just getDB. And this is going to handle all of the dependency injection for our database session for our application. And now instead of returning this list of books, we're going to return everything inside the database. So let's say db.query, and then as the parameters, models.books.all. And if we actually ran this application, we're not going to get anything back, and that's because we don't have any items within our database. So before we do this, I'm going to manipulate our post, our create book, to save an item to our database first before we go and test this. So right here, we say create book, we're going to be saying book of type book. We're still going to be passing in a book, but also we're going to be passing in the dependency injection argument that we did for a read API. So comma, db of type session equals depends getDB. Okay, and let's delete everything so far. Well, we can return the book. So let's just delete this first where we're saying append book to the list of books. And the first thing we're going to do is create a new variable or a new object book underscore model, which is equal to models.books. And this is going to be mimicking our models.py. So our ID, title, author, description, and rating. But again, we only have to handle these 4 attributes: title, author, description, and rating. And that's because SQLAlchemy is going to handle ID for us. Once we create this empty book model, we want to pass in all of the data from our book object into this book model object. So we want to say book model.title equals the book title, book model.author equals the book author, book underscore model.description equals the book description, and lastly, book underscore model.rating equals the book.rating. After we do this, we now need to add book model to our DB, which gets it more or less in the session of the DB. It actually hasn't done anything yet. We're just getting it ready to be committed to our database. And we can do this by saying db.add book model. And now we need to commit that model. So db.commit. All right, so we've made a lot of code changes. We created our database.py, which is all of our settings for SQLite and SQLAlchemy. We created our models, which is going to be our table and database for our SQLite. We then, within our books.py, made some adjustments where we're creating a dependency injection platform where we're saying db of getting our session and closing our database. And we are now calling our read API and create book from the database. Let's jump in our terminal and let's type in unicorn books :app -- reload to see this application in action. Let's open up our browser, refresh, and right now if we say read API and we say try it out, we're going to get a 200 successful, but we're not going to get anything returned, and that's because of our database is being completely empty. If we go to our create book and say try it out, we can see that we no longer have to handle any kind of IDs or primary keys. And now let's type in a title, author, description, and rating. So the title is going to be Eric's FastAPI course. Author Eric Roby. Description: the fastest way to learn FastAPI with a rating of 100. Let's execute. And let's go back to our read API and execute this API. And we can see that we get a ID of 1 now, and that's because our auto increment for our SQLite and SQLAlchemy is working. And then we have a book. This is pretty cool, and this is all going to a database. So now let's adjust our application for our put and our delete to now use the database. So our app.put book ID is going to be completely okay, but other than a UUID, we're going to say int. Our book of type book is okay, and here we're going to be passing in our dependency injection of our database again. So db::session equals depends get db. And we can delete just about all of this code. And here we're going to say a book model. So we're going to be creating a new instance of book model, which is going to be equal to our db.query. So now we're querying our database, and we're going to be querying the table of models.books. And we're going to say .filter, which is now us writing SQL commands or being able to, edit our SQL statement. And then inside our .filter, we're going to say models.bookID equals book ID. And this is going to say look through every record until models.books.id is equal to the book ID we're passing in, and then say .first. And .first just means when you find the record in the execution and return that one record, because there should only be one record of this instance because we're using the primary key. So there's no point in continuing the execution once we already find our record. All right, so now that we have our book model, we want to make sure that this book model is not null or none. And that just means once we look through the database, if that primary key doesn't exist, we don't want to be able to update it because the book doesn't exist. So let's do, before this raise HTTP exception, we're going to say if book model is none, then raise the HTTP exception. If not, let's continue executing this function. And you can highlight all this and press tab to be able to move everything to the right. And this is actually going to be called a guard clause. And a guard clause is just a way of ending a function execution statement due to variables or objects being null and kind of doing null checks throughout the application. Now, the other way you could do this is saying if model is true or is not null, then wrap the entire function inside that function statement or that if statement. but that's not good practice. Guard clauses make everything significantly more cleaner when checking if an item is null or none. So we're going to be using this guard clause. And then we're going to be doing pretty much the same thing we did for our post. So book_model.title equals book title. Book_model.author equals book author. Book_model.description equals book description. And then book_model.rating equals book rating. And then we want to add book model to the database and then commit the database. And then just so it's a little bit more pleasing, I'm going to return the book after we commit the database. Okay, this looks really good. Now let's redo our application and open up our Swagger UI. And again, since we're using a database, if we say try it out and execute, our application and data will still be there. So now I'm going to hop on over to our post. I'm going to create a new book where I'm just going to say title is string, rating is 0. Try it out, execute. If we go back up to our Git and we execute this, we're going to see we now have 2 books in our database. If we go over to our put, we want to say update a book. We want to update the book with a second ID. And I'm just going to change the rating to 50 just so we can see it in action. And then execute. We get a status code of 200 with our book information. If we scroll back up and check out the Git and execute this, we can now see that our book with the ID of 2 now has a rating of 50. Woohoo! So the put is working. And now let's just adjust our delete functionality to now be able to delete a book. So to do this, I'm going to delete all this code just like we did for the put. And we're going to want to pass in a book ID of type int now. And again, we're going to want to pass in our dependency injection of our database. So db of type session equals depends get db. All right, so for delete, we have to operate a little bit more cautiously. And what we're going to do now is we are going to first check to see if the record exists. So we're going to say book model equals db.query of models.books. .filter models.books.id equals book id.first to make sure that exists. And then I'm going to do the exact same thing for this arrays HTTP exception. So if book model is none, quick guard clause to exit the execution and just return an HTTP exception. And now we just want to get the deletion ready. So we can do that by saying db.query models.books.filter models.books.id is equal to book ID, but this time we're going to say .delete. And then db.commit. All right, and let's clean this up a little bit. All right, so I save the application. It's going to refresh our Uvicorn server, open this back up. And if we start by saying read API, try it out, execute, we're going to see we have 2 books, ID of 1 and ID of 2. If we scroll down and go to our delete book, and we say we want to delete book 2, execute, we get a null response, and that's okay with a status code of 200. And if we scroll back up and we execute our git, we can see that our book with the second ID has been deleted. So in this video, we created our database.py file, which is all of our settings of setting up our SQLite database. We created our models.py class, which is going to have all the tables and columns of our database for our books table. And then we enhanced our books.py file to now change all the CRUD operations to now query the database instead of saving it to an arbitrary list. And we probably can also delete this UUID from the top since we are now using just normal IDs. All right, and again, if you need any help with using SQLite or downloading SQLite onto your machine, I have a video for that. You can just click the video and it'll bring you to that, and then you can come back to our FastAPI course. Now you have it. You have a FastAPI application with all the CRUD operations that are now connected to a database. Congratulations and keep learning.